Oh, here we are. I found the record button. Okay, I think it claims that I'm recording. We'll have to hope for the best. Um, Now it looks like folks aren't in a position where they can ask questions. Do you guys have the ability, if you need to turn on sound? I'll just we'll go with this and see what we can do. Okay. So let's start. I'm going to keep this review pretty short. I want to just kind of talk a little bit about what's going to be on the exam, point you to some of the materials, update you on some of the things that I am still working on to help you prepare. So first off, a reminder that the final is on Wednesday, fairly early. So hope to see you all there. Good luck. The plan, it's gonna probably take the full 2 hours. The questions are going to be a little bit shorter than usual, but there will be more of them. I'm kind of modeling it based on the final that I gave last year, which was a good length. Um, that is an impressive. Oh my goodness, nice. Uh, I'm not sure if that's within fire code or not, but I won't report you. Um, so anyway, there's probably going to be as many as 10 questions. I think one of the things that I'm going to do though is I'm going to make it one of those things where you can choose to skip a question, like it'll be 100% where you pick and choose. I'm starting to like that approach because we've all had a situation where there's one particular topic that we're you're not strong at, and I don't want, if one topic is off, that you get penalized. Um, the exam is going to much more heavily weigh on new material. So there's going to be at least two, possibly three relativity questions. There's also going to be a question or two on dipole radiation, the radiation chapter. That's something that we didn't that we covered after the second exam, and so I'd like you all to be able to do basic for radiation. I'd like you to kind of understand the mechanics of the dipole approximation and just do basic calculations of dipole radiation. Where is it strongest? Where is it weakest? Electric dipole versus magnetic dipole, et cetera, et cetera. So those are the new topics that I need to and intend to test you on. With relativity, the emphasis is going to be on the practical aspects. So I want you to be able to do time dilation, length contraction problems. I'd like you all to be able to do problems involving um, four vectors, particularly kinematics. On that note, I posted yesterday two YouTube videos that I made. I didn't feel like I was able, in the short constraints of the lecture, to do that material justice, and I wanted to give you all exposure to it. So I posted, it's two videos, but it's really kind of one lecture's worth of material where I cover all of the momentum energy, the four momentum four vector um, stuff. And I will point out that that lecture has four practice problems. It might be a good idea, if you haven't watched it already, if you're going to watch it, to sort of hit pause after I describe the problem and do the problem yourself and then watch the video. Because, as is often the case, I point this out all the time, preparing most physics makes sense in retrospect when somebody explains the solution to you, but practicing actually getting at the answer. So I think that those four questions are important, or are good prep. Okay. Um, I'm going to also post tonight, I'm almost done with it, a lecture covering the transformation of E and B fields. I feel like I really rushed through that derivation as well, and I would like you to be able to do a transformation where if I tell you this is a setup with an electric and magnetic field, boost in the X or Y direction or whatever, what are the E and B fields now? I'd like you to be able to do that. That's the other thing to bear in mind that I'd like to test you on relativity wise. So that covers most of the relativity stuff. And I've just told you, with the radiation, I'm going to focus mostly on dipole radiation, but understanding the approximations and understanding the relationship between electric and magnetic dipoles. I think those are the main things. Um, as far as the earlier material is concerned, this isn't going to be like the extra credit exam that I gave the other week, in the sense that that one was literally meant to give you an opportunity to correct mistakes on the previous exams. There will be material on this one that will be new, that you might find a little bit novel. Comparatively. I mean, just I'm going to recap some of the topics that I'd like you to be familiar with, and then I'll open up to some questions and then talk about a few other things. First of all, the exam will cover a little bit of the standard. I'm going back in my book. Beginning of chapter 7, what are currents, or sorry, yeah, what are currents, electromotive force, that sort of thing. Um, Definitely stuff with, the possibility of induction, changing E and B fields, what they induce, being able to solve problems, mutual inductance, that sort of thing. Um, the full complete version of Maxwell's equations, um, displacement current. I think that those are sort of the major topics that I would like to cover from those. One thing that I haven't tested you much on is conservation laws. I think for conservation laws, I'd like you to have a good conceptual grasp of symmetries and how they relate. What are conserved quantities? What is the energy of an E and B field? What is the momentum of an E and B field? Um, I think those are the main things. There will be a waves problem of some sort, almost certainly. So just continuing to be strong in understanding how waves work. Again, I think understanding boundary conditions, something of that sort. Um, let's see what else. Uh, Again, I think there will be some stuff with potentials, being able to do the potential formulation, retarded potential, I think fields of a moving point charge, that sort of thing. These will be practical problems. It's not going to be on a lot of those really long derivations that we covered. And then again, I'm now, as I'm going through the textbook, back to radiation, understanding the approximations we talked about in class, and dipole radiation at a minimum, and maybe a little bit with a moving or accelerating charge. The accelerating charge kind of ties together both the radiation chapter 11 and chapter 10. So I won't say beyond a shadow of a doubt there won't be something involving a point charge accelerating, and then relativity. Um, I think that covers it. Let me just look at my notes and see if I missed anything else that I wanted to talk about in terms of like what the content of the exam will be. I just lost. Uh, Bear with me 1 second. There it is. Uh, yeah, I'm just looking through, seeing if there's anything that I missed. Um, No, I think that covers most of the key topics I'd like you to be able to do. As I said, I've posted the relativity lecture, and there will be a second lecture that I will post by tonight on EM transforms. Again, with both of those, I'm going to emphasize like mechanics. And those are good example problems that'll give you at least a sense of the kinds of problems that I'm interested in you being able to do. As always, I think, you know, the problem sets that we were doing with like kind of establishing symmetries and the directions of integration, that sort of thing. I think that those are skills that I'd like you to be able to demonstrate. And the symmetries problems, what I call two-sided problems, where you're connecting one integral to another, those are up right now. I think I'm going to try to dig up. We did the first time we did the help sessions, we did some problems where we were doing finite integrals, where we were integrating over a source. You know, that was the one where we did the ring, the finite wire, that sort of thing. I will try to get those up tonight as well. All of my lecture notes are on Canvas. I think that they're worth looking through. And the other thing that I was going to try to post is there is uh, a dipole group problem that I gave in last year's class that we didn't get around to this year. I'm going to post that and its solution just so you can see an example of a problem involving a dipole to help with prep. I'm going to pause here to open up for questions. And then I think that covers most everything at my end. Yeah. If folks don't have too many questions, the other thing I can do is I can circulate kind of the overview of topics that I just talked about in writing so that folks have it. Um, are there any topics folks would like me to go over? I think I see a hand up. The folks in the green room. Is that our classroom? I can't remember if our classroom is a green wall. Oh, okay. I can come down and say hi to y'all. I feel a little weird being on a Zoom just like less than a building over. But again, I think it's good to record this so that people can who can't make it have it. Let me look. Is anybody typing anything in chat? No? Seems like all right. Let's do this. If I actually, I'll come over if folks want to ask me a couple questions in person. But anybody who is not with the crew of people that's on campus, if you have questions, I think Aiden, Sylvia, and Connor, if you have any questions, feel free to type or unmute or otherwise we can keep this mercifully short. I think y'all are better off doing practice problems. Okay, I got some thumbs up. We'll end here. I'll walk over and just say hi, but otherwise, yeah, I might want to see a reprisal of what you did with the cooler. I'd like to see that in person. The cooler jug. Cool. Okay. Bye, everyone. Like I said, I'm going to post a few more materials tonight and I will send announcements. I will also try to recap some of the topics that I think would be good to focus in on. Otherwise, I'll see you all on Wednesday. Good luck. And in the rush on Friday, I didn't get to thank you all. It was a great class. I really enjoyed having you all. And yeah, Connor, I'll pull that together. Great. Bye, everyone.